The idea of graphing angles, the idea of putting angles on a graph, is going to come useful when we try to answer certain questions. And so I'm going to start with a follow-up from yesterday that's going to kind of dovetail into what we talk about today. Let's imagine that we have some angle, A. Here's our angle A. And I've told you that it's in the first quadrant. That's not actually language we've talked about. But if we have an axis like this, do you remember you would have talked about this in grade 9, so maybe that's a long time ago. If this is the first quadrant, what's this one here? Second? Third. Hey, you got it. Okay. So this angle's in the first quadrant, which means it's what? Acute or obtuse? Very good. How do you know it's acute? Yeah, right? Yeah, that's right. Less than what? Less than 9. Good. Right. So anything that's in the first quadrant, by definition, is going to be acute, right? Because the first quadrant ends at 90. So let's go ahead and make this a right angle triangle, because that's the whole idea with plotting angles. Now, if the sine of A is 4/5, then this isn't actually on the unit circle, because this 4/5 tells you that the hypotenuse is how long? If sine A is 4/5, what's the hypotenuse? What's sine equal again? What over what?
Hypotenuse is 5.
Okay, good, because sine is opposite over hypotenuse, right? So that's the opposite. That's the hypotenuse. So what side on this triangle should I make 5? Yeah, which is which one? Yeah, sure, this guy here. So this one is the hypotenuse, and that's equal to 5. What side should I make 4? Yeah.
The one that.
Up and down or left and right?
Up and down.
You got it. And that's the opposite. And that leaves what side? The adjacent, which we don't know. Does that make sense? So here, if I give you a sine as an exact value, you can actually draw it right on the graph. You can say, oh, this must be the angle. It must go up 4. Its hypotenuse must be 5. And the question is, what is its cosine and its tangent? What would I need to know its cosine and its tangent? I'd need to know the adjacent. Good. Go away. So I would have to know the adjacent, which I do not. I don't. It's right here, and there's no number. What do? I'm going to quit. I'm going to give up. I'm going to go home and take a nap.
Does that mean we all pass?
No, it means we all fail. I don't see an answer. Do you? I wasn't going to tell you, but yeah, that's good. What would you do?
I agree with you.
Yeah, absolutely. This is a nice, simple Pythagorean theorem question, isn't it? So we can use our friend Pythagoras' wonderful theorem to solve this. How would I set that up? Yeah, are we going to be adding? You're right, I know, but let me show the math. It'll make me feel special. I love the 3, 4, 5. So great. They're exciting, right? Are we finding a big side or a small side? Small. So am I going to be adding or subtracting?
Subtracting.
Subtracting is right. So what side should I start with if I'm going to subtract?
Hypotenuse.
Yeah, which is 5. So we'll take 5 squared. And what do I want to subtract from that?
The opposite.
Yeah, which is 4. And what do I have to make sure I do to that? Yeah, I have to square it. And then that would tell me how big the square of the adjacent is. But of course, I want to know how big the adjacent is, not how big its square is. So what do I have to do with that? Yeah, I have to take the square root. Good. Does anyone want me to draw like the square is coming off? It makes me feel fancy every time. I always do. Always do. Okay, and what do we get when we do this? I bet that somebody in this class can probably do this math in his head. What's the answer? Yeah, the adjacent is 3. Very good. Because 5 squared is 25, 4 squared is 16, 25 minus 16 is 9, squared of 9 is 3. Well done. Or maybe he remembered that 3, 4, 5 is one of the Pythagorean triplet patterns. Maybe. So, if the adjacent is 3, can we answer this question now? I think we can. In fact, Emily, would you like to tell me what the cosine of A is? Oh, okay. Would somebody else like to tell me what the cosine of A is? I'm going to put a little therefore sign. Therefore, cosine of A is what? What do we got? What do you got? Sorry? What'd you say?
Why did you go to the dumbest person in the room?
I didn't go to Caleb. I know I'm next to him, but I came to you. Don't say that about him. That was so
right
rude.
here. That
was so rude. I can't believe you would say that.
I already know that. You don't have to keep saying
yeah,
it.
my feelings are hurt on his behalf. That's okay. What does cosine always equal? SOHCAHTOA. Cosine is always? Ah. Ah. Say ah. Perfect. Yeah, it's adjacent over hypotenuse. So what's the adjacent? We just found it. Yeah, 3. And what's the hypotenuse on this one? Good. Oh, yeah, I felt that. You're telling me. It's not old because like many people like 80 and above would do that no trouble. It's just decrepit. It's a health issue. It's not it's a fitness issue, really. It has nothing to do with age. You're only as old as you take care of yourself, and I don't. Okay, we'll get there. Okay, and what would the tangent of A be? Yes.
3 over 4.
Yeah. No, I disagree. Why do I disagree?
No, it's 4 over 4.
Yeah, you got it. Very good. Yeah, because it's opposite over adjacent, right? Oh, so, yeah. Don't judge me. I think you were. I don't believe you. Okay, so this is a bit of an extension from yesterday, but it also dovetails into what we're going to talk about today, which is if I know the exact sine of an angle, I can always figure out the exact cosine and the exact tangent. Does that make sense? This is useful in construction. When you're building things, more often than not, if you are a carpenter, we tend not to want to have to get a protractor out and mark that point to get an angle like this. That tends to be less accurate than if we can just figure out what the length should be, right? Because a 90-degree angle is easy to make. You just get a square block and you square things up. So to get that last angle as a construction worker, as a carpenter, or as an engineer, you often prefer to figure out the tan, the opposite, the adjacent, because you can mark those measurements. And then the hypotenuse takes care of itself, and the angle takes care of itself. So that's a practical skill. If we know the angle we want in terms of sine, cosine, and tan, that is, in a construction term, in building something, it can be more useful than knowing that angle in degrees. That kind of makes sense? So if you knew that you wanted to make a triangle that had a straight side of 4 and a long side of 5, that's your sine, you could figure out what the other straight side needs to be just doing this way. Now, I understand completely that we didn't have to express that in sine, cosine, tan. We could have just done Pythagorean theorem. But the point being, if you know one of the ratios exactly, you can always know all 3. That'd be just as true. You could still use Pythagorean theorem if I'd given you cos in the first place. You could still use Pythagorean theorem if I'd given you tangent in the first place. Does that kind of make sense? All right. So now today, we're going to talk about something. Ternal angles. So let's say I have this angle right here, and it's 45 degrees. What does coterminal mean? What's that mean? What does co mean as a prefix? Yeah, partly, more than one. But like if I am, let's say hypothetically, Dana has a child there. He, yeah, I see blue, and being heteronormative, I know that means boy. So I see blue, so she's got a boy. So that's all that can mean. And because he doesn't have a name yet, it's looking like Wenceslas's. Like good king. Wenceslas, you're welcome. You probably should name the kid. You had your chance. So Wenny, as I'm going to call him for short, back there. If Dana decided that she really wanted Wenny to have two supportive adults in Wenny's life, and by the way, that's not necessary, but decided to say, Avery, would you help me raise my beautiful son Wenceslas?
No.
And Avery, of course, would say yes, because she's positive and supportive like that. They are doing what kind of parenting?
Co-parenting.
Co-parenting. What's cooperation mean?
Working together.
Yeah, it means operating something together. Okay, perfect. So co means together, right? There we go. Now, what about terminal? What is a terminal? That's true. Why? Why is it where you catch the bus? Why do they call it that? Because it's where the bus does what? Stops, which is important. Don't try to catch the bus when it's moving. That's discouraged. There's a lot of reasons not to catch the bus when it's moving, but it's a great idea to catch the bus when it's stopped. Terminal means to stop. It's where we get our word terminate. It comes from the Latin terminus. Yeah. It's also where we get our word the terminator. That's our Arnold Schwarzenegger. So, coterminal means angles that do what together? Stop. They stop together. They end at the same place. Could I make another angle other than that one that stops here? What could I do? Starting here, how could I get to that same place with a different rotation? I want to be the exact same place. So this is the line I want for sure. Perfect. Yeah, I could go like this. I could rotate the other way. What angle would that be now? Close. How would we get that number? How big is this angle in here again? 35. And we've gone the other way. If it had gone all the way around, what would that have been? 360. So this angle should be 360 minus 45. And then keep in mind, if we were rotating the opposite direction of normal, how am I going to indicate that using a number? It's going to be negative. So I'm going to put a negative sign in front of that. So it's going to be the negative of 360 minus 45. What's 360 minus 45? 315. And it's going to be negative, so it is negative 315 degrees. So negative 315 degrees and 45 degrees are coterminal. Co-terminal angles. They end in the same spot. Would they have the same sine, the same cosine, and the same tan? Well, what would the coordinates be here from your unit circle? 45 degrees have coordinates of what? Oh, you'll be firing these off like nothing in a week. Good, and? Good. And remember, we said that this ends up just being the cosine, and this just ends up being the sine. Right? That's how it works when we use the unit circle. So, what would the coordinates be at the end of this one? If it ends at the same place? It should be the same coordinates. Root 2 over 2, comma, root 2 over 2. You don't write a lot, get used to it. All right, like your signature. So it's like first time to buy a house. The first page, you're like, I'm signing my name to buy my house. It's so exciting. By the end, you're like, why does my name have so many letters? I hate my name. And that's why adults all have signatures that look like this. It's the first time they had to like apply for a loan. And by page 8, they're just like, oh, just my first letter and then a line. That's good. Anyway, there we go. My dad's signature? That exactly. Every time. Every time, all the time. Grade 11 report card. There we go. Grade 12 report card. Oh, got you covered. Anyway. Okay, who can give me another angle? That would be coterminal. That would have the same sine, the same cosine, have the same tan.
Clockwise.
Okay, we just did that. We just went clockwise. We got there.
Counterclockwise.
We did that first time, went counterclockwise. What else could I do? So we're going to go to the same place. We're going to end up at root 2 over 2, comma, root 2 over 2. Yeah. I could, but we're going to always define angles as starting here. So they can go up from here, that's positive. They can go down from here, that's negative. But for the purpose of the unit circle, we always start here. You're right. I mean, there's no reason you couldn't start here. It's just that you don't. But what can I do? How else could I get there? I feel dizzy, but that was a hint. I feel dizzy, but it was a hint. Do I have to do it again?
Yes.
No, I'm good.
405 degrees.
Hey, yeah, that's right. How'd you do that? We could go all the way around. Maybe it thinks you're stupid. Don't be so mean to. Don't be so mean to 405 degrees.
I want to get to this spot, but I'm going to go past it once of these and then get this.
Yeah, tell that to figure skaters, for God's sakes. They do like 80 spins in the air on ice with skates on. You go tell them that they're stupid. Yeah.
That makes sense.
Their
though.
entire sport is stupid.
No, they're sparkly and super fit.
Are you kidding? You ever watch figure skating? Because there's two. Let me tell you two things I know about figure skating. If I'm being honest, I find it a little boring. Having said that, second thing, that's got to be about the toughest thing I can imagine doing. I'm wearing skates. Now I'm going to dig in with a little jaggedy. So you know what I don't think is a good idea when I'm skating? Thinking, hey, I should take a part of this that's jagged and dig it into the ice so it stops my forward momentum. And like my face plants into the ice. But they do that on purpose and then propel themselves up into the air and then think, it's a good time to spin. And they spin, for God's sake. That's impressive. And now you can describe it mathematically. So, you're completely right. How did you get the answer to this, by the way?
I did.
Yeah, so you could do 360 degrees and then keep going, 45 more. And that would give you, what did we say? Very good. I will neither confirm nor deny that I was about to write 415. That's going to go to my grave with me, whether that's true or not. So, so 405 degrees is also coterminal. It ends at the same place. So I would like you, oh, I just did, okay, we're going to change this. See, this is why we pre-do these lessons. No, you don't get to do the same number. I want you to do 63 degrees. I want 3 angles that are positive, that are coterminal to 63, and 3 angles that are negative, that are coterminal to 63. And I'm going to ask you to start with this, write one down, and then pass it along.
Help me out.
Yeah, I don't know. Yeah, one.
Well, look at the examples above them and how we got those. And you can do anything of that nature. Could be only do one rotation. Could be multiple. Fun with both. So 3 angles that are positive, that go counterclockwise, that end at the same spot as 63, and 3 angles that are negative, that go clockwise.
I didn't write one. I can write one. No, it's my turn. But I wanted to.
I was just gonna say, if you repeated this with like cats and dogs and just did it as like different types of boyfriends and different types of girlfriends or something, like not clinging, cheaper and easier, more acceptable, less dangerous, I think really good selling points. But like also social and healthy and certified.
And have jobs.
Big E, that's a big one. Also good. So there you go. Anyway.
My cat is exact opposite from Cap's thing.
No, is that really the biggest thing? Because topic, death penalty.
I think it's 420 feet. I think it's 420 feet. What did I do?
Because I added it.
Oh, wait.
Okay, wait, can I do
Listen, if I did it wrong, just erase it.
I think you done good.
I need to
I don't-
double check because I think I'm the one that's stupid.
Yeah,
Okay. Whew. My heart. Well, I got that one right, and I don't know why my first one was wrong, but I don't know.
I blame you. You know. You know.
I need that.
Yeah.
It took me a minute, and then I got it.
Here, someone take it.
Bad influence.
That was big, and I did not mean to say something. There you go.
I don't know what I'm doing.
Oh.
I only figured out one. Oh, my birthday.
Somebody did the smiley face before.
This is totally going to be Caleb's answer.
Yeah, okay. Thanks.
I like that you said Friday face, but then you tried to like bring the show, you're still smiling.
It's crazy.
It's really hot. Who hasn't done it?
Yeah.
I have no idea. I need a calculator for this.
Yeah. Yeah.
Nope. Nope.
I think I was so pleased. I was feeling super guilty about that.
We've had
And
a
I-
last minute announcement for it.
And I thought about leaving my previous thing, but there's only like 9 people there, and I thought, oh, this poor lady presented. Like, I'm not going to be able to hide getting up and leaving. Yeah, oh, exactly, right? But she didn't try to make me feel good. But anyway. Okay, what do we got?
I have no idea.
Okay, let's talk about this. So how did we get 423? It's a good answer. I like it. What did we do? Yeah, we did all the way around and then up. Perfect. How did we get 783? All the way around, all the way around, and up. Good. 63, it's kind of lazy. Okay, there we go. And 1143, how'd we get that? Yes, very good. So if you were a snowboarder who also loved math, you could be like, sick 1143, bro. And there you go. And you'd know that that's like going 3 times around and then 63 degrees more.
I don't think anybody.
There you go. Yeah, exactly. Figure skaters can do that. So there we go. What about negative 297? How'd we get that? Yeah. So we went in reverse, but we didn't make it 360 degrees because we have to stop when we get to that 63. So that comes from 360 minus 63. Then we have to make that negative to say that we're rotating backwards. That we're rotating clockwise in this case. So I could have done all the way around once, almost all the way around twice, and then went. And that would have been what? 720 minus 63? What's that give me? Negative 657? Great. And then I could have gone 360 negative, 720 negative, 1080, but then like, oh, backtrack. Whoops. Okay. And that would be 1080 minus 63, and that gives me what? Very good. Very good. Does that make sense to everyone?
Yeah.
Okay, so the point of this is to say that any rotation can be assigned an angle, and any rotation has a sine or a cosine. But all of these, that are related, they're all the same. So we could put a little side note here. In fact, I'm going to put a little side note here. They all have the same sine, cosine, and tangent. Now, if this isn't making you feel like you need to question everything you've ever believed about trigonometry, it should be. This is friggin' revolutionary because it tells us that when we take our calculator and have it tell us an angle, and it says, oh, 50 degrees, do we know that that is the exact answer? No, in fact, there's an infinite number of things it could be. It could be 50 degrees, but it could also be a full rotation, then 50. It could be 2 full rotations, then 50. It could be an extraordinarily huge number of full rotations, and then 50. And there's a whole set of negative rotations that give you the same number. Does that make sense? So we've always thought of sine as giving you one angle. All of a sudden we discover every time we get a sine or a cosine and a tangent, and we use it to tell us an angle, that is in fact giving us an infinite number of answers. That can be infinitely many angles. All right, so with that in mind, I want to think more along that path. Could we please open the, there we go. Could we think of another angle that has the same sine value of 4/5? Remember that first question way at the beginning that I gave you? Sine of A is 4/5, and we made that triangle, right? And we said that if this is angle A, then this opposite side was 4, the hypotenuse was 5, and the adjacent was 3. Everyone remember that? Way back when we were younger and more innocent and not dead on the inside, before we flipped the page, when the pages were unflipped. Yeah. So we said that these coordinates are what? It would be, we need to flip the page. In fact, I don't think we put the coordinates on there, but we would say that these coordinates are what? How far over on the x is this? Was it? 3, very good. And how far over on the, how far up or down on the y? 4. Okay. And the sine, of course, comes from which one? Sine of 4/5. Is it that 4 or the 3 that contributes to the sine? The 4. And this hypotenuse of 5. Does that make sense? So is there somewhere else on here we could draw a line that is 5 long, where we also get an opposite of +4? Where the y value is also +4?
You could have the 17
Yeah, that's precisely the answer. If this 3 were negative, we'd be over here, wouldn't we? I don't love where I drew that. That's better. I know, wouldn't it be nice? I have applied for a grant every year to get a classroom set of these, because I thought it would be amazing. An amazing way to teach. Oddly, nobody wants to give me $25,000. I don't know why. I'd give me $25,000. Sure. If this were -3, but this were still +4, that would be 4. This would now be -3, but that's okay, because does that -3 affect our sign? No. So, oh, well, that was stupid. There we go. Yeah, okay. I don't really see it, if I'm being honest, but I'm glad that you do. That's like looking at clouds. Everyone sees something different. I see pizza, if you must know. Okay, so in this case, what would the hypotenuse still be? What's negative 3 squared plus 4 squared square root? The hypotenuse is still going to be 5. So this still has an opposite of 4 and hypotenuse of 5, right? And this little angle in here would obviously be A, right? Would have to. To give us the same dimensions, you'd have to make a triangle with the same angle. Does that make sense? Cool. But let's keep in mind, how do we actually measure the angle to this line? Where do we always have to start when we measure angles, when we plot them? We have to start here, to go across, right? So, if we went all the way to this flat line, how many degrees would this be? If we started here and went all the way around till it's flat. How much? Like if I started here, we kept going, until it's flat like this. How much is that? 180. Good. Okay. So this would be 180 degrees. But, and we'd call that angle B. I'm just going to give it a name. We'll call it B. Angle B is equal to 180 degrees, but we don't make it all the way to 180. How shy of 180 are we? 45. This one wasn't necessarily 45. This one is just angle A. But you've got the right idea. We have to take this much away. I don't know what A is in this case. That's 180 minus however big A was. And yeah, if A were 45, that'd be 180 minus 45. So here we have two angles that have the same what? Possibly. I haven't asked. But I have asked. I know that they both have a y coordinate of 4. Yeah, so they have the same. Yeah, they have the same opposite. They have the same hypotenuse. And opposite over hypotenuse is sine. So they have the same sine. Do they have the same cosine? No, because negative 3 over 5 isn't the same thing as 3 over 5. Do they have the same tangent? No, because 4 over 3 isn't the same thing as 4 over negative 3. So they don't share the same cos. They don't share the same tangent, but they do share the same sine. Two angles can have the same sine. Whoa, man. Whoa. Okay, what else do they have in common? Fair enough. My son is in the principal's office sick. Could we please go get him? I'm going to assume my wife's going to take care of that. Also, it's like 2:03. Suck it up. Like, honestly. Anyway. Yeah. Through most of the day. Just power it out. I don't know. Yeah, I guess if you're vomiting, you should go home. I mean, don't get me wrong. If I were him, I'd be trying to go home too. But I'm here. Anyway, they have the same sign. They don't have the same. They have a different cos and a different tan. Now, what I want you to do is use a calculator and tell me what exact angle is in fact sine of 4 over 5. If the sine of angle A is equal to 4 over 5, A must equal 1. Tell me that. And if the sine of B is 4 over 5, what must B equal? So use your calculator and get to those numbers. Make sure your calculator is in degrees mode, by the way, when you enter. Wow. Because I've told you the sign. You need to look up the angle. How do you do that? Yeah, you got it. We got it. That's right. That's so. Is it meridian mode? Probably. Yeah, it is. See here where it says rad? I got it. 4 divided by 5 is the second function. No, not second function, I need to use sine 8. Second function for that case. 4 divided by 5. Oh, for God's sake, it's not like this. I don't know. Maybe that's. That does not make sense. So what do we get when we do that?
53 degrees.
Yeah, that number makes sense. Okay, 53 point.
13010.
Okay, so we would just say it is the sine inverse of 4 over 5, right? And when you do that, you get 53.1. Okay, and then here, we would just say it's the sine inverse of 4 over 5. And the answer is, of course, then just what? Oh, no. Are these both right? Yeah. This angle isn't actually 53 degrees. We know that it's actually 180 minus 53. Why doesn't my calculator know that? Yeah, sure, of course. Because if there's an infinite number of angles that it could be, how many answers do you expect your calculator to give you? It's going to give you the first answer. It's just going to tell you the smallest possible angle with that sine, with that cos, with that tan. So your calculator always gives you acute angles. Calculator always gives you acute angles. And you have to outsmart your calculator. Is angle B actually 53 degrees? No. I want you to tell me what angle B actually is. Good. It's not 53. It's 180 minus 53.1, and that's going to be 126.9 degrees. Well, 127 degrees. Good. You've got to outsmart the calculator. Well, that's going to be a problem. But no, it's not. It's not. It's like saying that the reason we have cars is so that I can get in and press the gas and shut my eyes. That's a bad idea.
Not if you're in a bigger car than anybody else.
I'm still going to disagree. I'm going to say that the lift bridge disagrees with you. Yeah, sure. Hey, that's true. And one day there will probably be a calculator smart enough that you can say, hey, give me this angle, and we'll just do it, and it'll make like a bloop, bloop, bloop noise and give you the answer, and you'll go, great, that's awesome, thanks, R2. But until that happens, you're going to have to be smarter than your calculator. I look forward to the days when we don't have to be smart about anything, when I can walk out in the middle of traffic and all the cars will just automatically stop, and they'll have like robot voices that honk and say, get the hell out of my way. That'll be great, but until that day, we have to be smart. Yeah, hopefully. And then like I'll have a little robot device that says, I'm walking here, and I won't have to say it. Like it'll just happen. But until computers can road rage for us, we have to be smart enough to do it ourselves. Likewise, until the calculators are smart enough to know what angle you actually want, you can't just use sine inverse or cos inverse or tan inverse and plug the number down. You have to actually ask yourself, did I want this angle when I punch sine equals 4 over 5 in? That's the angle my calculator is going to give me. Or did I actually want this angle? Yeah.
Or because you may know that they have the same denominator and all that. So identity goes back instead.
Aha, very good. And that's when we get into certain types of problems, there's going to be problems where we have to use the cosine to solve it. Because the sine is ambiguous. The sine will give us two answers. There'll be times when we have to use the sine, because cosine could potentially be ambiguous. So that's good. It's going to lead us into having to know when to pick what ratio. It's very good. So, next page. The next page, and the last page is going to be your homework. So this is the last page we're doing together. Is something we call the cast group. The calculator always wants to give us an acute angle when we look one up. But But in reality, it's possible to have obtuse angles as well. An obtuse angle has a related acute angle. And what I mean by that is what we just saw here. Every obtuse angle, every angle like angle B, will have the same sine or the same cos or the same tan as that original angle A. So we have to watch out. The calculator wants to give us A. We need to ask ourselves, is A really what I'm looking for? Or is it possible that I'm looking for B, an angle that's obtuse, that's bigger than 90? And with that in mind, it helps us to know a couple of rules. So let's start in this quadrant up here. For this angle, the x value is always going to be positive or negative. Let's say positive. The y value is always going to be positive or negative. Positive. Good. And of course, hypotenuse is always positive. No matter where we go, the hypotenuse is just a length, so it's always positive. So if hypotenuse, x, and y are all positive, sine is going to be what? Positive. Cosine is going to be, and tangent is going to be positive. So no matter what angle you pick, if it's between 0 and 90, the sine is going to be positive, the cosine is going to be positive, and your tangent is going to be positive. Do you suppose that you could tell me that same information for this angle here? I think you could. Anyway, we're going to find out. So see what I did there? I said that the x-coordinate and the y-coordinate in this case must be positive. No matter what, hypotenuse is always going to be positive, and I use that to denote sine, cos, and tan. Whether they're positive or negative. Are you going to give me the answer? Because I don't want the answer. I want you to write the answer down, and then other people do it too. Yes? Oh, yeah, of course. Yes, of course. You guys are in charge of your own lovely functions. Yeah, no, I've always been kind of weirded out by people asking me if they can. It's the reason I didn't become an elementary school teacher. I don't teach high school. I don't want to have to think about your bodily function.
I think it'd be a lot harder.
Oh, way harder. Don't you think? Way harder. You couldn't pay me enough money. I mean, first of all, they wouldn't pay me because they'd fire me very quickly. But I would be very bad at it. I mean, I just didn't want to have something more than novels. I don't know if, like, I think in every field I've ever worked in, people seem to have breakdowns. That's the part of being human. Sometimes you break down. You get things. They're hard.
Yeah,
break down
and
and fix it.
you can just throw that car away.
And then eventually you can't fix it anymore. Right? You're left. And you're gone, and there's a shiny new Prius in your driveway. That's how that goes. I didn't mean divorce, I meant death, but I mean, same idea.
It sounded different.
Like if you come home and there's just a new car in your driveway. You see, the problem is that'd be really bad because at first you'd be excited, right? You'd be like, hey, I got a new car. And they'd be like, oh, it's not mine. Yeah, that would be depressing. Well, I'm glad we had this talk. Okay, what do we think here? The coordinates of this particular angle and any angle in this quadrant, in the second quadrant. What do we think?
Negative, positive.
Yeah, so the x value is always going to be negative because we're on the negative side of the x, but we're always above the x-axis, so the y value is always going to be positive. Well, with that in mind, tell me about the sine, the cos, and the tan. And if it helps, you can kind of sketch a little triangle here. You can remind yourself and say, if this is the angle, this must be the opposite. That'd be the hypotenuse. And that'd be the adjacent. So with that in mind, sine. Is the sine in this case going to be positive or negative? Okay, sine is going to be positive. What about cosine? Yeah, it's going to be negative. Why is it going to be negative? What is the cosine? Yeah, cosine is just x. And x in this case is negative. So any angle in this quadrant is going to have a negative cosine. What about tangent? Can you go back to your previous note? How do we find tangent when we're on the unit circle? Yeah, it'd be a negative because it's just y over x, right? Opposite over adjacent. And if y is negative and x is positive, that's just going to be a negative divided by a positive. And of course, a negative divided by a positive is a negative number. So in the second quadrant up here, any angle that comes and lands here, in other words, any angle between 90 and 180, is going to have a positive sign, but it's going to have a negative cosine and negative tangent. You can prove it right now, just to test it. What's an angle between 90 and 180? Give me a number.
125.
Okay, 125. Look it up. Take the sine of 125. It should be positive. Take the cosine of 125. It should be negative. Take the tangent of 125. It should be negative. Let's make sure that this is true. Try that. Tan is a negative divided by a positive, so it'll be negative. Good. Good. I didn't screw it up. I taught this lesson once and badly screwed up the whole thing. It was a disaster. I think I ruined those kids in math probably forever. They were all going to be accountants. Now they're all like something else instead. What are they? Shoot. Okay, sure. Okay. Oh, listen. Go to school to be an accountant. See how much math you do. See how much math you do that you wouldn't. See how many times things you would never expect to come up in accounting come up? Accountants do crazy math. Did you ever take an accounting class? I didn't. I had good friends in accounting. Ask for Tushnik about accounting math and like tax math. And ooh, yeah, it's crazy. They do. You got to be good at math. Good mathematicians. And I screwed them all up. So good. So this is between 90 and 180. If you want to write that, I mean, you don't really need to write that. You can see it. But sometimes it doesn't hurt to draw it. And what about this down here? See if you can tell me the same information for down there. Yeah. All right. What do we think? Okay, good. They're going to both be negative. I like that. So we have here that both coordinates will be negative because it's behind the y-axis, so the x is negative, and it's below the x-axis, so the y's are negative. And that makes the sine what?
Negative.
Sine has to be negative because sine is just the y value. What about the cosine? Negative, because it's just the x value. And what about the tangent? Positive. Why is it positive? You're right. It is positive. Yeah, it's a negative divided by a negative. That's not clear at all, but whatever. I have faith in you to figure out what that means. Don't let me down. Yeah. There you go. Put it on the list. And then, what do you suppose I'm going to put in this last one here? Oh, I just meant like a line here. But okay, sure. You're good. You don't need me to draw this out. So what do you have? So the x is positive, the y is negative. And that means that, tell me about, what will the sign be? Sign's going to be negative because the sign just is the y value on the unit circle. The cosine is going to be positive because it just is the x value on the unit circle. And the tangent, negative, because in this case, will it be negative over positive or positive over negative? I ask because I forget, but I think this is it. Anyway, it's negative. That's right.
No, it's positive.
Is it positive over negative? Did I screw it up?
Yeah, because this one.
Right. Yep. But I might have screwed that one up. Let's see. I mean, it's y over x. So yeah, I was right the second time, and thus wrong the first time, which should surprise nobody. It certainly doesn't surprise me. So yeah, this one here should actually be positive divided by negative. Whoops. Okay. Now, what this means is that any angle between 0 and 90, sine is,
Positive.
cosine is,
Positive.
yes, sine. Tan is,
Positive.
is still sine. Now, for angles between 90 and 180, sine is,
Positive.
cosine is,
Negative.
negative. You know you want to make me happy by doing this well. Tangent is, especially you.
Negative.
Thank you. Okay, and then between 180 and 270 in the third quadrant, sine will be,
Negative.
cosine will be,
Negative.
and tangent will be
Positive.
positive. And lastly, if your angle is between 270 and 360, sine will be,
Negative.
cosine will be,
Positive.
and tangent will be
Negative.
negative.
I
Good.
think we have these of these.
Now, we give this rule a name, and we call it the cast rule. And it's a good mnemonic device to help us remember this. It means that anything in this quadrant, the cosine is positive. Cast. So A next. What's the A stand for? What's positive here? True, but yeah. That is true, it's true. You're not wrong. Yeah, anything adjacent, both true. All is the word I was looking for. But they're all good answers. They're good. These are all positive. Step one. What about over here? S. What's positive here? Sine. So sine is positive. And lastly, cast. Tangent is positive. Good. So that helps us remember. Any angle that's in this quadrant, all the ratios are going to be positive. Over here, only the sine will be positive. Down here, only the tangent. Over here, only the cosine. So that is going to be our takeaway from today. Monday, we're going to start using that to do all kinds of fun and exciting math. And I do mean fun and exciting. I love this part of the year.
You say that.
That's not true, but I say it for lots of them because I like this stuff. The stuff I don't like, I keep it quiet about. Just like my students, right? I regularly mention that I like Dana, and I just don't talk about Avery because I'm not really a fan. And it would be rude to say that, so I just keep silent. Same thing with the topics in math.